With both holes cut and my little guide rod here resting in the bottom of each, I can also see the rod is hugging the terrain tight. So now it's time to get some pipe in here. Pipe cut to length, and while I don't know if it matters, I just feel this is a little bit too smooth on the outside. So in order to maybe help it bond with the concrete, I'll roughen it up a little bit with some sanding paper before sticking it in the ditch. And at last, one roughened pipe with a really good angle to evacuate water. Way more than our 2% minimum. And pulling out the measuring tape, we can confirm the vertical rebar has really good solid coverage, even if water were to creep in along the outside of the pipe. Now I just need to put down the rest of these before we do some final rebar preparation. Just want to point out that optimally I would have used a perforated pipe behind the whole wall and then led that out at the lowest point. But that would have required a much larger diameter outlet than these, weakening the base more than I'd prefer. Still, this should more than suffice. I have these two plus a backup where I know water will want to arrive. But keep in mind that water will always want to go down. That's why I followed the slope down along the back of the wall. This point plus its backup, which is the lowest point on this whole level, catching all the water going down behind here. Still, we have another lower level for this foundation, and no matter how much of the water landing behind the top level we catch, some will always end up down here. And should the finished wall somehow cause water to change course, we might get a lot of it down at the very bottom. In either case, without dedicated drainage, this lower level would become a proper swimming pool on the bottom, where water would collect until it could rise up to the next level to drain out up there. And with enough time and freeze-thaw cycles, this could cause a failure of the whole wall. Hence, I have this pipe, which sits at the very lowest point of the entire base. So everything ending up inside this area has a way to escape. It also, of course, has a backup of its own. And that's it for drainage. Now I'll just note that since I'll need to be able to get in and out of this area when I'm pouring concrete, to get up to the highest part of the base, I've not fixed the rebar down here to the bedrock quite yet. But while these bars are for now sitting loose, the rest are now permanently affixed. Which brings us to the next part. Remember when I drilled these holes, I made sure to keep the right distance between them, so the rebar would align with the holes in the formwork blocks. Drilling perfectly vertically is hard though, so now these are just jutting out in all directions with random distances between them at the top. And to fix that, it's time to break out the level once more. Sticking this on any piece of rebar will tell me how out of level it is, so that I can bend it into place. But if I just grab the top and bend, I'll end up curving the entire bar. So instead, you'll want to slip something stiff over it, so you'll only be bending it at the bottom. You could use a length of pipe. I'll use the narrower handle for my garage jack. Just slipping it down to the bottom and using the level to ensure I bend the bar to the correct position. Be careful not to bend too far though, because doing so weakens the steel and you really want to avoid bending it back and forth several times. But once I have all these perfectly vertical, I can move on to the next step, which is horizontal reinforcement. Now, with my vertical bars both fixed and straight throughout, I can get to working on the horizontal. Now I've given my ditch one last go with a power washer, since that'll be hard after this, and I'll start up here with this slightly below 90-degree corner. But we still need to keep paying attention to concrete coverage around the bars. And down here, getting those 5 centimeters to the edge won't be a problem, but we also need to have some coverage below and above the bar. So down here it's a little bit tight, but we can still make that work as the absolute extreme end of the horizontal bar. So we can start thereabouts, and I'll try aiming to put it in this area, meaning some 35-40-ish centimeters from where it has to bend. What I'm going to do next is take this appropriately long piece of steel and find where that 40-ish centimeter mark might be. Then I'll slip my jack handle onto the bar. Put a foot down on the rest of the bar and just pull up. Now I want to make sure that it's a pretty rounded corner to preserve the strength of the steel. You don't want a really sharp bend. Not quite there. And that should pretty much just about do it. It seems I got a little bit sloppy, and this is a bit longer than what I intended, but I think we can still make it work. Having slipped the steel into the ditch, I can see when I pull it into place that it's actually going to end up at that tight spot. So I need to make absolutely sure I get the coverage right. And that's where something like this comes in handy. This is a rebar support chair, and by putting this underneath the bar, this one will give me either 4 or 5 centimeters ground clearance depending on how I set it, and 5 centimeters coverage to the sides. This way, the steel will be kept safely off the ground and with enough distance to everything else that it will both do its job and not rust. Now this is meant to go into the final pour, but I don't like them and I'll take them out. They could trap air bubbles inside of them. Plus, it feels weird to stick weak pieces of plastic into my super strong concrete, but while positioning the rebar, they can be a great help. And with the chair in place, I can also put a board across my form and measure that I do have enough coverage above the rebar as well. And this looks to be fine. And as I move down the form, I can also place these chairs sideways to ensure I have those minimum 5 centimeters both above and below, in addition to the distance to the wall itself. Next, I'll tie my horizontal bar to the verticals using this copper-coated steel wire. And there are specialist tools you could use for this, or even a tie gun that spins the wire around, but I'll just be using regular pliers. This is tricky at first, but eventually you do get the hang of it, and the wire really keeps the bar firmly in place. The first horizontal bar is now securely fastened to the verticals, but since my wall is longer than the longest bars I could find, I need to make a splice. So I'm leaving this last chair in place for just a second until I get a second bar in here. When people splice rebar, you typically see something like this, where the bars are tied closely together in what's called a contact lap splice. Those are very practical and easy to do, but these do not allow any concrete between them, making this splice not quite as strong as a non-contact splice, like this. The distance between the bars should be at least 1.5 times their diameters, and never more than 15 centimeters. With both bars fixed in place, I meet those criteria, and I do have the minimum overlap of 60 centimeters met as well. But I don't really like that these aren't fully parallel, so let's fix that. So like I said, I did not exceed the maximum distance between bars in my splice, but I'd still like to be more confident about reinforcement in this spot. And since it's also one of the tallest parts of my base, which will have the most lateral pressure acting on it from behind, I wired in a second bar in parallel with the other one. Now, my horizontals are all on the outside of my verticals, and there's a good reason for that. Retaining wall bases will typically call for a pair of bars at the bottom in parallel, but I don't have any bars on the inside. And the reason is that when this backfill wants to push outwards, the bars in the front of the foundation will catch that force. Meanwhile, this granite is really not going anywhere. Nothing will really put any tension on the base from above, only compression. And with my rebar securely in place, it's time to start prepping for the pour. I've added more reinforcement to my form, I've packed dirt and stacked concrete blocks up against it, and closed off the last remaining openings on the bottom. Now I just have a ton of little gaps and irregularities which concrete might want to seep into, which means it's finally time for the duct tape to shine. While sealing off cracks with tape, I thought I might add some triangular profiles like these as well. Nature doesn't like hard corners, so smoothing those out with something like this will add a little bit of longevity to my wall. But the weather report tells me I'm short on time, so I'll only be putting in a few in a couple of strategic locations. And there we are. A whole lot of tape and a few strategic profiles. Now let's make concrete. For this part, you need a few more things. A mixer, or preferably two. While it's nice to mix more batches at once, the main thing is that once you start you cannot stop, so I have a spare as backup. You need something to dump the concrete in. This is a bit small, but it'll do. You need a smooth shovel like this to get the concrete wherever you can't just dump it. And you definitely want a vibrator on hand. I bought this for this project, but these are often easily rentable as well. Next, the ingredients themselves. You want a good high-strength concrete appropriate for your environment. While the designation might vary from location, you definitely want something which can hold up to the EN206 exposure class XC4 for carbonation, and wherever it gets cold, XF4 against frost and de-icing chlorides. You'll also want to add a latex admixture like this stuff, which I will be putting into my water at a 1:5 ratio to make my concrete less permeable, better at withstanding chlorides and cracks, and easier to work with when wet. In the nice to have corner, there's a few more items you might need. Various masonry tools like differently shaped trowels and also a float. And a tiny shovel is always handy. You'll want some sturdy buckets and drill attachments for mixing smaller batches in those buckets. Note that these things break easily, but they're super cheap, so you'll want several. Now let's get to it. This bit is not a one-man job, so I recruited a nearby doctor in molecular neuroscience to help out, and together we're making the driest mix stated on the bags. 2.2 liters of latex and water per 25 kilo bag is not the easiest to work with, but you really want as low a water content as you can get away with. Not much time to catch video when pouring, but we've gotten to this corner, meaning I can now stick the last remaining verticals in, make them straight and wire the last bit of horizontal rebar to them. And that's all done, fixed and straightened. Since my anchoring epoxy sets in just a few minutes, I can also keep loading concrete in here with no problem. Now I vibrated the part of the formwork out of place, which means this bit is no longer level across. I'm gonna have to partially eyeball effects, but the point is always keep a bubble level handy, also when pouring. I'm also doing this as an overnight operation because of weather conditions, and I realized that I should have gotten some better work light. If I have any regrets now, it's just I should have gotten more people to try to help and run my other mixer instead of keeping it in reserve. Still, all things considered, this is going pretty well. Well, that was quite the ordeal, but now the foundation is finally done. And for wet curing it, I've covered it in old cotton sheets soaked with water. Burlap would be even better, but the main point is to ensure the concrete never has a chance to dry out. Normally you'd cover this in plastic, but I'm getting lots of rain right now, which helps in keeping these sheets wet. Still, there's really no such thing as wet enough when curing concrete, so I'm continuously ensuring this is absolutely dripping. The why is simple: if I can keep this soaked for a week, I'll have literally double the lifespan of this foundation for the cost of a few liters of water. By the way, Tyler Labe has a video with really cool data on the effectiveness of this bit, which I'll link below. And the sun returned, so I had to break out the plastic. Now, conventional wisdom says not to wet cure latex modified concrete, which I guess this technically is, because that might negatively impact chloride ion permeation resistance. But I came across an article in Aspire, the concrete bridge magazine from 2022, with data stating that's not the case. So I'll be wet curing to my heart's content. Having wet cured for a week, this base is now strong enough to start receiving the blocks. Now you might want to leave the formwork in place so as to protect the not fully hard concrete of the foundation, and only remove it when you get to finishing. But my terrain would make teardown a bit tricky when the wall proper is built, so I'll be removing it now. Now, this concrete is still curing, and it will keep doing so for weeks and months yet, so I'll want to keep corners, and rebar in particular, safe from sharp hard impacts. But since it's still curing, it's still consuming water, meaning you can benefit from keeping it wet for longer, especially if you do this in temperatures dropping below 20 degrees Celsius. Water is what goes into the hydration process, which is what gives concrete its strength and durability. And with a stable supply of a lot of water after the concrete has set, you will get great hydration and, as a consequence, great concrete. As for tearing down the actual formwork, the crowbar will be needed since most of this is screwed together from the inside of the form. But by getting all of the screws I put in from the outside out of the way first, like these, I'll be minimizing the amount of stress I'm putting on the base by pulling and tearing at the woodwork. And now for the moment of truth. Jiggle, jiggle. And isn't that looking great? Let's open up the rest. With most of the formwork off, I see my duct tape trick to round off corners worked really well, whereas the triangular profiles didn't. This looks to be due to poor vibration up top, plus dry concrete, but I can live with that, or I might come back to it later. In general though, I've gotten very good consolidation of this concrete. This is nice and smooth with just a few small air bubbles visible, but there are some areas, usually near the top, with poor consolidation, like this. Now, the surface is rough, but that's just good. But the side should have been smoother though, and that's on me. Moving on, I find more areas that aren't well consolidated. Dry concrete and little experience, plus a focus on vibrating around the steel bars, is probably why. That's still not terrible, but this gash needs some urgent care. And I can touch up this while I'm at it. To do so, I went and got a bag of this stuff. A fiber-reinforced repair mortar, which should fill all the little cavities nicely and provide strength and protection. This stuff sets quickly, and since I'll just be repairing a small area, I'll just be making a small batch. And for small batches, a hand drill is all you need to mix. A few minutes later, my large cavity is filled, and I've smoothed out the rougher areas here as well, making it time to move on. This is the very last of the formwork, and as you might have realized long ago, I was not wearing my thinking cap when putting this in place. This is a spot where form oil would have been helpful, because with form oil on the inside it would have loosened more easily. Now it's just going to be really tricky for me to get this out of the way. It's something I should have realized back then, but there's nothing creative crowbarring can't handle. But with all the formwork at last gone, the last thing to do before stacking my Legos is adjusting the drain pipes. On the outlet side, you want a bit of overhang so that water doesn't come out and run down along the wall. But on the inlet side, you want the hole as flush with the wall as possible, so water can easily drain in instead of sitting against the concrete. And the multi-tool is practically made for this job. There we go, perfectly flush and ready to receive. Spraying water in behind this foundation, we see everything is draining into the pipe and coming out the other side of the wall. And if you're wondering how I'll keep this from clogging up, we'll get back to that when the wall itself is ready. And to make the wall itself ready, it's now a question of slipping blocks over the vertical rebars and making sure they're completely level. So I'll be making ample use of these risers down along the length of this whole thing. You may need to use risers both on the inside and outside of the wall, because all these blocks need to be perfectly level. And unlike the base, the vertical is the most critical direction. Across is just a function of the vertical, while lengthwise is actually the least important. You should still try to make them level that way, but your wall won't collapse if it isn't 100%. But please use risers to make sure the blocks are vertical at pretty much all costs. With the base, it's not really a problem if this slopes outwards a little, so long as I don't put any load on top of any little overhangs. Whereas the blocks, if they lean outwards, you will eventually get a catastrophic failure. Now, if it's just not possible to get it perfectly straight, you may allow the wall to lean slightly inwards so that it may rest against the backfill back there, but the goal is getting it straight. As for getting the risers out, it's quite simple. When the blocks butt against one another and have more blocks stacked on top, the friction of that contact will lock everything in place, so I can pull these out once I've put in the concrete. But we should also talk rebar. Your rebar table, as mentioned previously, should detail the placement based on height of wall, and for my wall, that means one 12mm bar horizontally at the bottom level, on the inside of the verticals. Then, another one on every second level up. Now, since I have bottom levels on different heights, I'll be getting quite some overlap, but that's pretty much the definition of not a problem. As an aside, when you're handling concrete elements like this kind of block, you absolutely want gloves with something like a thick leather surface. They're not the most tactile gloves, but the alkalinity of the concrete will not be hindered by any kind of textile glove, which I learned the hard way when I put down this road last year, and I'm not eager to repeat those chemical burns. Back to stacking, the actual surface of my base is so uneven that I've had to do quite a lot of adjustment. But that same unevenness also gives my next level of concrete that I'll pour great purchase with a lot of surface area to adhere to, and the new concrete will seep into any small gaps with no problem. As for dealing with the steps up on my base, I told you that you'd see when we got there, and we've now gotten there. This block is going to make one step, thanks to this level. I've parked the last block at the bottom of the slope, which I can mark here, and I can then mark the top of the slope where it meets this block. Pulling a straight line to the top of that block, I can then make a straight cut down the diagonal to where it meets the previous one. So let's do that now. A couple of lines cut, and I've pretty much given up on my clothes by now, but in the middle here you can see my disc can't reach all the way in. But there's an easy fix for that. All you have to do is make some small incisions almost all the way in here, and then this bit will be ripe for the angle grinding, like so. And then this splits itself nicely in two for me. Almost ready, just one slice into the wall and this is done. Some places you might need to cut blocks into interesting geometries, like this one, which has to be both a step and a corner. And if you mess those up, like this, you might not want to waste both the effort and the block you've cut. And you can. So these big gaps on the bottom can be closed off with some old plywood and just a simple clamp. You just put this in place and any concrete I pour will fill the gaps nicely. Obviously with a board on the other side as well, and I'll naturally want to verify that the blocks are level before pouring anything. Then it's just a question of drafting a neuroscientist to help with measuring chemicals and get back to pouring new concrete. When pouring the inside of the blocks, running the vibrator is even more crucial than before, as I cannot even check the consolidation along the inside of these walls afterwards. Good vibration also helps ensure these gaps don't become waterways into the wall proper later on. But suddenly I find my first few courses are in place and they'll be curing for a while, so I'll also water this bit religiously. Now, in a perfect world, I would have liked to finish one course, then stack and pour into the next course, and so on, continuously all the way to the top. But that is far beyond the means of a couple of people mixing in place, so this is the only way I can make sure everything is level, has all the right rebar in the right place, and is well consolidated. Because unlike the base, there's so much going on in here that I can't just set everything up and pour on concrete. For one, I need to make sure I can get my vibrator all the way to the bottom. Getting more courses in, I noticed I made a bit of an oops here earlier when stacking the bottom courses. This gap you see here exists because while these individual blocks are pretty level lengthwise, along a longer line I have a slight downward curve. And one way to prevent this could have been to pull a string from one rebar here to the other far end of the wall, and then ensure the top of every block followed the line of that string. But I didn't. Still, this does give me an idea. A gap like this isn't a big problem, and if I can build in a slight incline, those 5 centimeters I'm missing due to my mistake with the topmost foundation step might be compensated for in a very gradual way. And indeed it could. Working my way up to where it all began, I've managed, over a maybe 8-meter span, to reduce the gap from 5 to just 2.5 centimeters. And that will reduce the amount of cutting and adjusting I need to do up here quite considerably, while not leading to a very perceptible slope on the top of the wall. Building the wall this way shouldn't be a problem though, but it does mean I need to wait a few days between sets of courses, since the fresh concrete remains vulnerable to impact. And in the meantime, I'm keeping it soaking wet. That includes not just the top surface, but also seams between blocks and the block faces themselves, as capillary action will draw moisture through them and help hydrate the fresh concrete inside. I also found a neat use for AI in this, in that I can ask an AI model to account for hourly local temperatures in my area over the days since I poured the concrete, and adjust for an optimal 20-degree environment. It won't give me quite laboratory condition curing, but it'll be a lot better than the 1 week rule of thumb, especially if you have highs in the day and lows in the night with big differences between them. The building phase is rapidly approaching done, but in case you've been wondering what exactly is going on down here, you'd be right to assume it's not really part of how to build a wall. I just wanted sort of an integrated utility closet here, meaning I now need to give this little area a bit of a ceiling. And I don't have any blocks for that, so I'll need to build a formwork around all of this and install enough rebar to keep that ceiling up. So I'll just do that in a real hurry. here we are, some kind of improvised formwork with a bit of reinforcement all tied up. This feels pretty sturdy and I can't really push it out easily, so maybe it'll hold. Look at that, it held! And now it's time to keep this soaking wet for at least the next week. Now I know a lot of people will remove formwork after just a day, and that might be okay. But if you want maximum durability, you're going to want to give your concrete time to cure well before forcing it to support its own weight. So that's why I'm keeping this form in place for at least a week, and the shoring underneath for another week or two after that. Now the first week is up, and I'm really excited to see how this turned out. It's actually been pretty hard not to open this up sooner, just to have a peek. And behind door number 1, some really excellent consolidation. Alright, I'm happy, but let's get back to the wall. So in the process of stacking and watering, you'll probably end up flooding some of your block cells. And you don't want any excess water in there when you get back to pouring fresh concrete. So one handy way to fix this is to just drop the now dry sheets you've been using for wet curing into these cells to wick out the water, like this. And when it's time to pour the topmost course of your wall, you want to keep the steel coverage in mind. Now, my verticals are deep enough that they have ample cover, but I have horizontals up top, which would only have a couple of centimeters between them and air. In addition, letting these side walls be the roof means that unless you have an absolutely perfect bond, which you won't, then moisture will in time creep down along the inside of these side walls and crack the sides of the blocks open. So I'll be using some plywood clamped onto the blocks to raise the top of my pour to a nice and even 2 to 3 centimeters along and around the entire wall. And here's what that looks like when pouring. We have a couple good centimeters all around the top of the wall, and that cap is going to ensure water atop the wall will not penetrate between block face and grout. And in addition, it'll help in protecting the rebar by providing additional cover. And all of this is, of course, level on top. Once the final concrete has hardened enough that you can't easily dent it with your finger, you know what's coming. It's wet cure time. So break out those wet blankets again and keep this all soaking wet for a week, or preferably 2. We have now gotten to the stage where many block manufacturers would say, great, you're done, wall's finished, and structurally that's true. This thing would stand upright for decades as it is right now. But it's not too pretty, and more importantly, it could still be a lot more durable. So to fix both issues, I'll do just a few more things. First, these seams between blocks can be filled in, so